Hi everyone, this is Mrs. Keener. We're going to go through this test review. So much is just a quick review, almost the same exact questions, but then other math problems do require a little bit more effort in thinking, like number 5 right here on the front. Okay, ready? Here we go. We have a graph here. We don't know what the equation is. Maybe we'll have to find it. You ready? Is this graph increasing or decreasing? So since it's increasing from left to right, is it growth or decay? We're going to say it's growth. There's a loud noise outside. I don't know if you can hear that or not. Sorry if you can. Okay, let's talk about the left and right end behavior of the function. So as x goes to negative infinity, circle this. What's the y value? This y value is at -2. So if you have a horizontal asymptote, then we say the function is approaching -2. And as x goes to the right, then we're going up to positive infinity. Okay, as x goes to the right, where's the arrow pointing? It's just pointing up. So that's going to positive infinity. Whereas this levels off at a y value, this does not. The domain of all exponential functions, that's what the name of this unit is negative infinity to positive infinity. Now the range is either from the horizontal asymptote up or the horizontal asymptote down. Since our graph is above the horizontal asymptote, then the range starts at the horizontal asymptote and goes up to positive infinity here. That's our range. What is the equation of the horizontal asymptote? It's -2. Okay, so do you see how that horizontal asymptote is important here, here, and here? Okay, find the equation for g. So the first thing that we're going to say in the formula that g equals a times b to the x plus c, we're going to say, sorry, I'm at the bottom of the video. We're going to say c, we know c is equal to -2. Okay, then we showed you that you need to find 2 points. Now this one is not as easy as the other ones. So originally I said look for exponents that make this 0. So then b to the 0 would be 1 and it would go away. Okay, but look at this. Now we could estimate, we could guess, but guessing's not real mathematical. We're not going to guess this value, and I'm not even going to guess this one. I'm going to use this 2, -1. And I think it's good for you guys to see a different way to solve this. And then 3, 0. Am I on the screen? We're good? Okay, you ready? Here we go. My first attempt. My y value, so I'm going to use the first y value, -1 equals a times b to the power of 2. So there's my x and there's my y, xy. C is my horizontal asymptote, which is -2. Okay, if you're like, I don't know what to do, that's okay. Just, we know we can add the 2 to the other side, so we have 1 equals a times b squared. Now you should look at that and not sure, you don't know what to do with that yet, so I'm gonna hold that. That's on hold. Okay, let's try our other point. The other coordinate point is 3, 0. The y value is 0, so the y value goes here. A times b to the power of 3 minus 2. Move the 2 over. So we have 2 equals a times b cubed. Okay, now we have 2 equations with 2 unknowns, which is okay. You guys have actually done this before. We're going to use substitution. So what we're going to do here, watch, we're going to solve this for a. Do you agree that I can divide both sides by b squared? And I get a equals 1 over b squared. Do you see that? Now we're going to take this and plug it into a of this equation. Can you do that? Yeah, you can do that. You did that starting in 7th or 8th grade. It's called substitution. So instead of a, I'm going to do this. Okay, what do you think? We substituted 1 over b squared in for a of this equation. And what do you get when you have b to the 3 divided by b squared? If you have 3 b's on top and 2 b's on the bottom, 2 cancel, and what do we get? we get b equals 2. We get just a b, right? b equals 2. Sorry about that line. It's like not in a great spot. b equals 2. Do you agree? Huh? What? Yes? That's why we learn the exponent rules. If you have b cubed over b squared, it simplifies to b. All right, if b is equal to 2, what's a equal to? A was equal to 1 over b squared, but we know b is 2. So 2 squared, this would be a equals 1/4. Final answer is we put it all together. G equals a, and the base is 2 to the x minus 2. Is that right? Yeah. Okay, we're at growth. Good. Growth with no reflections. Good job. Okay, hopefully that's the hardest one on the test. Yeah, hopefully. Okay, review. Ready? Left and right end behavior. Here we go. We have a table now instead, but we do have, ooh, look at that. We have a reflection, so be careful about that. As x goes to the left, instead of f of x, I'm going to say it's h. h of x is going to, that's a real big number. So look on the left. Is that leveling off, or is it going to an infinity? That's going to go to an infinity. And as x goes to the right, h of x, is it leveling off or going to infinity? This looks like it's leveling off at really close to 1. So that's going to be our horizontal asymptote at 1. Identify the domain and range. Domain is the same for all of these, negative infinity to infinity. Now the range, it's either going to be above the horizontal asymptote or it's going to be below the horizontal asymptote. Fix the light. There you go. Maybe. I don't know. Okay, think about all these numbers. It starts here. You should do a little sketch. It starts here really big at 513, and then it just gets smaller and smaller and smaller and smaller, and then levels off at 1. So if this is 1, then are all the points above or below? They're all above. So we're going to, the range will be from 1 to positive infinity. Equation of the horizontal asymptote, we've already said it twice, y equals 1. And good thing I have a graph here, because this is asking, is A positive or negative? Well, is this graph above or below? It's above the horizontal asymptote, so A must be greater than 0 because h of x is above. H of x are all the y values, all of them. All the y values are above y equals 1, which is the horizontal asymptote. Careful, this is h of x and the horizontal asymptote is h. We use HA. Okay, we're going to keep going. I'm going to do just as much as I can. And that's all I can ask for. Oh, this is a good one. I kind of wanted you to do this on your own. Which of the following equations represents an exponential function that decreases without bound? Okay, ready? Decreasing with bound is this. This is with bound. With bound. Because, why? Because it's bounded by this asymptote. But decreasing without bound means it's going to negative infinity. So this is decreasing without bound. Increasing would look something different. Okay, ready? This is fun. So this base is greater than 1, which means it was going up like this. But then this negative, what did this negative do? This negative boop, 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 reflected it down. So that's what it looks like. Okay, what do you say? Is that decreasing with a bound or decreasing without a bound? This is decreasing without bound. Oh, the question says without bound. So is this decreasing without bound? Yes. Okay, let's do it again. Ready? What's the base? The base is less than 1, which means this is a decay function. Now, is there a negative here or a negative here? No. So there's no reflections, which means this is it. This is decreasing. You agree it's decreasing. Yes, but is it decreasing without bound? Is it going to negative infinity? No, it's decreasing with bound because it's leveling off. Cool. Okay. What about this one? So this is a no. The question was yes or no? No. This base is greater than 1, so it starts off going like that, increasing, a growth, but then it has one reflection, and that is over the y-axis, so that's a y-axis reflection, which means it looks like this after the reflection. Is that decreasing? Yes, but is it decreasing with or without bound? This is decreasing with a boundary because it matches this picture. So does it decrease without bound? No, it decreases with bound. All right, those are fun. Ready? Might be able to go a little faster here. Consider the exponential function and just consider this. You ready? What is this? This is a reflection here, a y-axis reflection. Let's just answer the questions. What's the value of c? C is the number on the end, and for this one it's going to be -3 because that's a horizontal asymptote. As x goes to infinity, so as we go this way, the function is it increasing or decreasing? If you're wondering, what do I put there? It's decreasing. Decreases with a boundary. Do you agree it's going down? Yeah. The value of b is such that, so it's not asking us to actually find the value of b, it's asking if it's less than 1 or if it's greater than 1. But we have to undo the reflection. So this reflection is again a y-axis. So this is on the y. We're going to reflect it to go like this. Now, after the reflection, it's a growth. Do you agree it's going up now? So b started off greater than 1. And then the reflection reflected it over. Use this graph picture to find the values of a, b, and c. Okay, we're hoping this is easier than the front. We start with c. C is the horizontal asymptote, so that's 3, and then we need to pick a couple points, and we want to, what do we want? We want this to be 0. So let's pick x equals -2. Does that work? It didn't work on the front. Does it work here? It does. It does. Okay, let's pick another one. What's another easy one? We might have to go down and use this one, -3, -3. You ready? Get set. Here we go. Y comes first. We're going to use y equals 1. A times b to the -2 plus 2, and our c value is +3. Just double check it's positive. Here we go, people. Subtract 3. 1 minus 3 is -2. Do you agree this is b to the 0? And b to the 0 is equal to 1. So what do we have for a? We have -2. To draw lines to keep my work organized. Okay, we have to use the other coordinate point now. So that's why we find 2, but we know a is -2. We don't know what b is. My new x value is -3, and my c value, it's a lot to keep track of, yeah? You have to stay organized here. Okay, subtract 3. Remember, I run out of time at 15 minutes. This is not 0, this is -6. Next, I'm going to divide by this -2. If 3 is equal to 1 over b, then b is equal to 1/3. Sweet, we did it. And you should write the final equation. Let's do this one real quick. True or false? Is f decreasing with bound? I'd say true. Sorry, the answer is true. Is the value of b a fraction? That's a no because of this reflection. This had a y-axis reflection here, so this is false. And the value of d is 4. Is the y-intercept at 4? Or the horizontal